Hey everyone, it's that math magician. On this video, we want to work through a problem where we can show that two triangles are congruent. And we're going to want to prove that using a flowchart. So our hope is that we can use one of the conditions we have to show congruency on these two triangles. And just for a quick recap, remember that two triangles are congruent by two different things. The first is the two triangles have to be similar and they have to have at least one equal side. So if we can show that the two triangles on our example problem are similar and have an equal side, then we know that they're congruent. So let's go ahead and jump right into this example problem where I have two triangles here, kind of joined together, and we want to prove that they're congruent. Notice that I have this top triangle here. We could call it ADB. That's the top triangle there. And we have this bottom triangle, CDB. And we want to prove that they're congruent. So what I think we need to do is just sort of look at those two triangles and talk about what they have in common. Do they have any angles that are equal? Do they have any sides that are equal? And we want to look at the markings that we see. Well, I noticed that here at angle B, that they both have two angles there, and they both have those hash marks, which means that they are equal to each other. So I know that this top angle at B and the bottom angle at B are equal by those little marks. So we should go ahead and write that into our flowchart. To write that in, I cannot write this. I cannot say that the measure of angle B equals the measure of angle B. I can't do that because there are two angles here at B. I don't really know what it means that B equals B. I don't know what angle you're referring to. So we got to be careful when we're writing these out, because if I see two angles at one point here, I can't just say B equals B. What I want to do instead is I want to name it. And I can name this top angle just by tracing it with the three letters that make up the angle. So for example, this top angle, I could call it A, B, D. Notice that I'm just tracing out that angle, tracing it out, getting the three letters that make it. So I could call it ABD, or I could call it DBA. Both of those names are perfectly normal for that angle. We just got to pick the one that we want to use. So I'm going to go ahead and call this the measure of angle ABD. Okay, ABD. Now I'm going to name the bottom angle. Since I did ABD, I'm going to call the bottom angle CBD. So I know that the measure of angle ABD equals the measure of angle CBD. So we're good right now. I have two angles in each triangle that end up equaling each other. So now let's keep going and see what else we see. Well, I noticed that the top triangle and the bottom angle are both using this side here at DB. Imagine that I took both of those triangles and I sort of split them apart. They both would be using that side DB. So since they both have that side in common, what we can say then is that DB equals DB. And that's a true statement because they both have that side in common. And that's good for us because right now we have an angle in common and we have a side in common. All I really need at this point is another angle to prove that they're congruent. So I'm looking around and some of you might be thinking that C and A are equal. They sort of look like the same angle, but I don't have any markings there that can help me out, right? There's nothing there that tells me that A and C are equal, so we can't talk about that. But what we can talk about are the angles at D. Notice that at this point D, that on this bottom triangle, we know that we have a right angle. And since this side here, AC, is a straight line, and I know this part ends up being a right angle, it means this top angle here, right, for the top triangle, this means that this would also have to be a 90-degree angle. Because if I have a straight line and one angle is 90, the other has to be 90. Remember, supplementary angles add to 180. So I think I have my final angle here in common. So let's go ahead now and just write that out. Again, I can't just write that the measure of angle D equals the measure of angle D because there's two angles here. So again, let's practice naming this out. I could call this guy ADB. So ADB, I'll write this out. Let's see, the measure of angle ADB is going to equal, let's now trace the bottom one, CDB. Those two angles are equal, the measure of angles CDB, and that is going to be enough for us to show that these triangles are congruent. We can conclude now. I'll go ahead and write my conclusion on my flow chart. We can say with great certainty now that triangle ABD is congruent to triangle CBD. And we know that it's congruent because we used angle, side angle congruency. That is a complete proof to show that those two triangles are are congruent. And the way we did it is just by identifying what was equal to what. Okay, that's what you want to do with these problems. Look at the two triangles that you have and see what angles are equal, what sides are equal. Sometimes, and I'll say this, sometimes one of them might be hiding. Notice that I wasn't given that top angle there was a right angle. We have to use our brains, and remember, supplementary angles are going to give me two 90-degree angles. So if you can identify what's equal and what's not equal, you'll be able to show that any two triangles are congruent. It's that Math Magician, and I'll see you on the next video.